All right, let's go ahead and take a peek at this page from the workbook. This is from the 4th grade book. It is exercise 2 from chapter 6. Let's see what we have here. The top two problems, you are comparing 6/13 and 5/8, and you're comparing 6/11 and 3/8. So basically what we're doing here is we are going to either A, find a common denominator, B, find a common numerator, or compare them to another number. Now, in this instance, you technically could compare for the first one your fractions to 1/2, seeing which one is closer to that 1/2 mark. For the sake of time, I'm going to do a comparison of numerators. So over here on the right, I have 6 and I have 5. I'm going to turn this into two fractions having the same numerator. So I'm going to go ahead and I am going to see what number they both have in common as a multiple. 6, 12, 18, 24, 30, 5, 10, 15, 20, 25, and 30. 30 is the number that I'm looking at here. So I'm going to change both of them into 30 over something. So when I multiply 6 over 13 and I'm changing it into something over 30, I need to figure out what exactly I'm multiplying by. I know that I am multiplying by 5 because when I count by 6s, I count 5 times to get to 30. So because of that, I'm going to do the same thing on the bottom, multiply by 5. 13 times 5 would be 50, 65. All right, and our new fraction is 30 over 65. And we are comparing that to 5 over 8. Now, mind you, again, we're trying to have common numerators, so we're going to change this fraction of 5 over 8 into something, or 30 over something. So we write our original fraction, and we are trying to make it equal 30 over something. We're looking for an equivalent fraction here. What am I multiplying by? Oh, I'm multiplying by 6. How do I know? I can count by 5s 6 times until I get to 30. I'm going to do the same thing on the bottom, multiply by 6, which I know is 48. My new fraction here is going to be 30 over 48. When my numerators are the same, I check to see which of my denominators is smaller. The fraction that has the smaller denominator is the fraction that's going to be larger, for the reason being simply that your pieces are larger. Your whole is split into less pieces, so each of the pieces it's split into are larger. You would get more pizza sharing with 48 friends than if you shared it with 65. All right, and we would do the same thing for the next problem. We could look for some sort of numerator that was in common, which I think would be the easiest for this one because I can see already that 3 is a number that can be turned into 6, so we're really only changing one fraction here. So I have 3/8. Let me use a color that you can actually see. We have 3/8, and we are going to change that fraction into something, or 6 over something. I'm multiplying by 2 to get to 6, so on the bottom I'm going to multiply by 2. 8 times 2 is 16, so I'm comparing 6/11 and 6/16. Mind you, the number that has the fraction that has the smaller number on the bottom is the larger one because you are sharing, again, with less people. All right, let's go ahead and I wanted to show you a comparison to another number here on the bottom. This is number 4 in the workbook, and we are going to label this number line. The top is going to be labeled as, the top tick marks are going to be labeled as one fraction, and the bottom set is going to be labeled as another. So the first thing that you would need to do is count the number of tick marks on the top to see which fraction we're trying to label here. So 1, 2, 3, 4, it takes 5 on the top to fill in the hole. So we can label 4/5. So we have 1, 2, 3, 4/5 is here. Let's look at the bottom. We're looking for 6/7. We could go ahead and count them. 1, 2, 3, 4, 5, 6, 7 pieces to your hole. So we can look for the 6th one. 1, 2, 3, 4, 5, 6 out of 7 here. Now we can compare it to 1. We're comparing to 1 because each of these is super close to 1. All right, let's go ahead and look. B says 4/5 and blank make 1. This is asking us if we had a number bond here, like a whole 1, and we were trying to figure out what the missing piece was before we got to a whole. We can look back at our number line and we can say, oh, we're only missing one of those pieces. Well, what does one of the pieces on the number line represent? On the top, it represents 1/5. We're missing 1/5 here to get to a whole, which is 5/5. So we're missing 1/5. 6/7 and blank sevenths make 1 whole. So again, 1 whole, and we already have 6/7. How much are we missing? Well, if we look, we're only missing one piece out of how many? 1 out of 7. So we're missing 1/7. Which fraction is closer to 1? So we're going back and we're saying, all right, from 4/5 to 1, we can see this giant chunk. And from 6/7 to 1, we have a smaller chunk that's missing. So which fraction is going to be closer? 6/7 is closer. If 6/7 is closer to 1, then which fraction is greater? 6/7.